più la voce. Benvenuti. I'm going to switch to English. We have to speak to the wide audience. So I'm here with big guys from Intel, one of the fathers of this project, and we also have one of many fathers of this project. I'm Massimo Banzi from Arduino. We want to tell you a little bit about this project, the features of the board, what you can do with it, and we also have some people from the Intel team, and we have Christian Maria, who is the lead software developer of the Arduino software. Christian, no, stand up, turn around, say hi. That's enough. He's gonna get emotional and cry. So I wanted to actually, I would like you to go ahead and give a little overview of the process.
Sure.
What are the technical.
Sure, no problem. Thanks. Thanks very much. It's great to
Yeah, totally.
Like I said, my name is Pete Dice. I'm the product line manager for the Port SoC at X1000, and I've also had a bit to do with the Galileo board. First, I'm going to introduce some key players. Sean McBurn from Ireland. Can you stand up? Sean is the lead hardware developer for the Galileo board, so he puts the board together, make sure the rails are right and all the functionality is there in the hardware. And then David Knowles, can you stand up, please? David Knowles is the software engineering manager for Quark. He provides all the open source drivers to the community for the stock itself, and he makes sure that everything is extremely high quality. So he's the guy who drove most of this forward from the software side. And there's probably a large number of other people who don't want to stand up and take a bow at the moment. So we'll give you so here we are at Maker Faire Rome. Just a few weeks ago, we announced the Quark SoC and the Quark family at IDF in San Francisco, and that was a major question. Like, what does that mean for Intel as far as open hardware or open architecture, industry standard software, and what's fully synthesizable mean? Well, let's talk about something. Well, first of all, we run off the top of the tip of the tree Linux right now. That includes all the industry standard tool chains. And it's an open hardware architecture, as Sean's putting out all of the files for the board, all of the hardware bill of materials, and all the specs on the boards. They're all open source, and that's another departure that Intel doesn't normally do. Normally we go through OEMs like Dell and HP and IBM, and everything is kept under wraps and all brought forward at the same time. Here we're doing things differently. Here we're open sourcing the hardware to the community. So that's something which I hope you will give some feedback on. If you see us, doing anything, which isn't quite right, please let us know. We'll go and correct that. We're not saying that we're perfect on the first instantiation of us going up to work, but we will learn. We also have in the chip a security technology which can be turned on if needed later for other applications for the Internet of Things, and that includes a hardware root trust. So that's something that can be brought forward if wanted by the community. Also, this is designed for low-cost, small form factor boards. The board itself is right priced for the education market today, and we believe that other people will be able to make derivative spins off of the board for a similar capability. Also, the chip itself is fully synthesizable, so we can design and manufacture it with flexibility and longevity in mind. So we'll be able to make this same component in different forms going forward from Intel. So the Galileo board itself, We have a Quark SoC running at 400 megahertz. It's got 512 kilobytes of embedded SRAM and a 256 megs of DDR 800 on the board. We also have a 10100 Ethernet controller, a USB 2.0 host port, and that does more than just the keyboard and mouse, but it is a full-blown host stack for USB. Also on the back side of the board, which you can't see here in the picture, which will show off here in a minute, is a PCI Express 2.0 full mini card slot. So you can plug any device that would come into a laptop in the PCI mini card form factor will run on this board. With as long as it has the Linux drivers for it, it can be integrated onto the software stack. Also, we have a micro SD slot, which is expandable to 32 gigabytes. So there's no limit as far as the applications that can run on the board. We also have an 8 meg NVRAM flash if you want to store something locally and keep it persistent inside the board outside of the SDRAM you can. This is made for the maker community for development. It comes with it is a USB 2.0 device, but that's fully programmable. Also, the SPI programming is fully programmable. From the Arduino software IDE, it automatically updates the firmware, but if you wanted to go ahead and update a different firmware, you can do that through a separate SPI programming port next to the flash. We also come with a 10-pin J-type debug port, which supports a low-cost OpenOCD debug solution. We also have an RS-232 UART port on there, which is disguised as a 3.5 millimeter audio jack, but please, it's not audio. It's made to take up less room and still offer full RS-232 capabilities off the serial I/O while you're running things and doing things with the USB 2.0 device port. You can also be doing serial capture and debug on the side. Right now, people are asking how many layers the board is. Right now, it's a 6-layer board, and it's 10 by 7. We were making it a 4-layer board at the last minute. We had to add in a couple of extra components, so the number of layers went up to 6, but it can be easily brought back down to 4. That's what it's designed for. It was just a matter of timing. We wanted to make sure that we were here at Rome at the Maker Faire to get this product out the door. So that's why we haven't done full level integration with 4 layers. But we'll look to do that on the next generation. Also, of course, we have a full Arduino compatible interface with 6 channels, A/D converter, and that's actually running on a 12-bit A/D, not the 8-bit, which comes on the other Arduino boards. And then we have a 25 megahertz SPI port, which is a little bit faster than the 4 meg default. And then we have a UART port, I2C, the 14 GB programmable interrupts, and then 6 PWMs right now. We're going to look to expand that interface as we move forward. We're open to feedback. If you see something which is amiss or something that you want, let us know at maker.intel.com, and we'll see what we can do about maybe integrating that on future release. As far as the open source hardware and software goes, of course, we're supporting the software that Massimo's teams come up with. I think it's fantastic. We want to keep that compatibility going forward. And also, the software stack which we're running can run on a Mac, it can run on a Windows laptop, and it can run on a Linux laptop as far as the development environment goes. So whatever you're using today, you should be able to work and program for this board. And then the Linux firmware, like I said, we have full open source drivers. We're not holding anything back as far as the driver stack goes. And a full open source tool chain with GCC. We also support ICC, Intel compiler chain. And as I mentioned before, all of our BOM, all of our schematics and board models, you can go ahead and download them and take a look at them. And of course, we have full data sheets. We have as much documentation on the board or the chip that you could possibly want. I think some of them were 5,000 pages of documentation at the moment. If you want more, we can make more. But really, it's a lot of great reference material. You can go as deep as you want on this board, and that's how we designed it to be. right? You can start with the Arduino software IDE, and then you can immediately get down to Linux if you want, or stay away from it and keep the Linux as firmware. It's up to you, right? You can also bring forward all the Linux calls into the sketch, right? So it opens up a variety of possibilities there, which we've been working with Massimo's team to make sure that it will be a fantastic experience. So I kind of wanted to stop for a minute and give you a chance to comment and maybe do some questions.
But I think it's interesting because why is it going now? I think that's the question. It was working until 5 seconds ago. Great. So if my voice was open source, it could be fixed. So the mechanism is it brings to the maker also some interfaces that you only see on PCs. So you have PCI Express. So it's a type of interface that you don't see on any other kind of device. So I know that in a few days we'll see online people blogging projects where they plug in all sorts of weird PCI Express around, and they're going to make it do crazy things. And also obviously the performance of some of the peripherals is quite high. So again, you can do some pretty interesting work with this, but also the fact that it's the PC, essentially a PC, that's going to squeeze the PC a smaller chip. I think again, that's interesting because all of the amount of work that exists around that on the X6 platform can be made to run on this, which is again another interesting plus that Intel is bringing to the data community. I think if you want, we could actually ask people if they have questions. It's probably much better to answer questions than just for us to keep talking. So if somebody has a question, you can also ask the question in Italian if you want, and we'll try to translate it, but if you do it in English, it's better. Over there?
I think I heard the Intel CEO during the announcement, he said he answered a question he was asking, does this run the entire instruction set, the x86 instruction set? And he said no, apparently.
Yeah, I can talk to that.
Yeah, the question was I went on the website and it apparently Intel suggests that when you compile to the 586. So isn't that a little bit lifting in a way, or how does that work?
So it depends on the software stack that you run. Right? When you're going to compile your own software stack, you'll take the GCC, right? You'll set that 586 and it's fully IC compatible with the .586 extensions. What it doesn't have is about 686 or any of the higher end instruction sets that we've come out with and an extension we've come out with over the last 10 years. It doesn't have any of that. It's a very simplified programming model, and it was made to run with the Quark core. Right, the Quark core is a .586 compatible core. So that's what he meant by no, it's not full, but yes, it is IC compatible. From that point of view, you just have to say switches.
So you can cross compile easily on like your processors, like
yes,
you compile on 586.
Yeah, you'll have binary compatibility at the application layer, or at the application level. Obviously, depending on the item you have, it might be different. But if you compile it for the Quark, it will run an Atom or run an full, which is another great feature. Now if you compile it for 4, I mean, it's way it works because it doesn't have all of the switches set right for Quark. And at some point, you'll get an instruction that doesn't understand what's going up. And I think from a bigger point of view, that's kind of an exciting play. You can start on the Quark and port your applications on that.
Thanks.
Actually, I have 2 questions. You said the design is an open hardware design, and that all the files are being released. What license are they being released under?
CCA, Creative Commons.
Second question is, a lot of evaluation boards put out by larger companies often don't ship with a true MAC address on the device. They randomly generate it, or you have to assign one specifically. Are the boards being shipped with a unique assigned MAC address for everyone?
Yes, and the MAC address is on top of the PCI Express connector on the back. You can also change it if you want in firmware to hardcode something else, but we try to use the platform data as well.
Posso in italiano? Prego. Allora, io sono il Pablo da Palermo e siccome la rete dei Pablo sta crescendo in maniera esponenziale, come la conoscenza di tutte queste potenzialità, io mi chiedevo, già ci sono queste cose, ma se in maniera più strutturata, anche se ci saranno in futuro delle potenzialità strutturate di dialogo sia a livello di informazione che a livello di diffusione sul territorio, sia per quello che riguarda il prodotto, sia per quello che riguarda la potenzialità. Perché noi per esempio, oltre a fare diffusione della tecnologia open source, che penso proprio all'interno dello sport, come si vede quando poi resta scritto? Io per sintetizzare perché non esistono vanno al punto. Vuoi sapere quali potenziali dialoghi tra la casa madre e anche esperienze che si vogliono di okay, so the activity is about it's from that in Palermo. So he was wondering if there was a possibility of communication and connection with the network of fund labs and hackerspaces and Intel so that they can, apart from basically the technology, maybe the communication channel going on, because obviously what they do, they can implement the technology at the local level, they can engage communities, so maybe that's more a question for you or
Well, I would say that, Maker and Intel.com is designed for that type of interaction. I would say go there first. And I would also say if you don't think you're getting the right response, let me know. I'll give you my card.
Okay.
And we'll make sure that we have.
Io non traduco, sarebbe che maker.intel.com è il sito che è nato apposta per creare questo tipo di comunicazione. L'unica cosa che serve puoi scrivere lì, se non ricevi la risposta che vuoi, scrivi a lui ti dà il biglietto da visita, la fate così.
I should also say that Intel has about 300 official makers in our own internal community, which we're going to be working a lot of external parties to help to bring the support and the goodness and the knowledge out and be working together on that.
Intel ha anche 300 maker all'interno proprio della società. Questi qui aiuteranno a comunicare verso l'esterno e creare questo ponte tra le comunità. Sarà esponenziale virtuale. Quindi, grazie. Prego.
Just on the same thing, this is like Intel, a very big company running something in the open source world. There is another world, that is the Java world, that is pushing a lot on the Internet of Things. Do you have some point of contact with the Java technology world, or are you planning to do something like this?
We've been looking at the Lua interface there to get up to Java. We currently have EmuTech, who's one of the demo makers for the Intel booth. Their dollhouse that they have wired up is running Lua up to their application. So you can take a look at that and you can ask them more questions about what they have experienced so far. And as we go forward, we will be supporting Java as well in the commercial side of the application. Yes.
How much is it going to cost?
We have an MSRP right now set up less than $60. Now, what you'll find may differ depending upon distribution channel or where you go to buy it. It might be a little more, it might be a little less, but we'll say $160.
What does Microsoft think of all this?
Microsoft, so that's a great question. I was in the New York Maker Faire, last weekend, and I was talking to the Microsoft team about this stuff. Microsoft wants to play at it, and if you go and you talk to the guys at the booth, there's a huge maker community inside of Microsoft that wants to play with you at this. Unfortunately, the Quark can't run Windows 7 and Windows 8 right now. We're going to have to talk to them about maybe a future product. But that's something which we're definitely talking about. They are key partners as well.
Are you evangelizing the organization software community? Do you have to, or do you take the messages, or do you have to have an evangelize?
Right now, we've been working and focusing all of our efforts on the software IDE and on the Linux stack that's underneath it. You can easily run an RTOS on this. When your DXWorks is already booted on this platform, I know. So you can look forward to more as we go forward. But we want to try to focus on a few things and get it out the door and learn from that. And then bring the key learnings back into the products. Right? Not just the board products, but also the silicon products. And then help to drive that back out.
So we have time for one question because we are running out of time. We're running out of time. Oh, John. Yes, please.
Hi. So the design is open source, but I was checking on the internet. Where is the Quark SoC available? Are you planning to make it available to distributors like Faire, so we can make our own board?
It will be available through distributors, yes.
Just the plain SoC.
Just the chair.
Yes.
My name is Massimo, 2014. Right now, we've really been focused on getting the board out, spinning it, getting the feedback from the community, so we can really capitalize on that. But our CEO did say at the conference 2 days ago that we'll be making the SoC available. You know, I don't have pricing at this point in time, because right now our focus has been really partnering with Massimo and his team and really getting this. You know that we have some things that we have to change. So I think the silicon itself, we'll get that next year.
Okay. Oh, there's one last question.
Will the Arduino shields run on this board? Can you plug in there?
Yes, we have a list of validated shields as well. We have 60 in-house that we were able to get a hold of. We're working through the shields and trying to correct any potential issues. There's a lot of AVR specific calls which we're finding in the library. We're talking to the shield vendors on, and we're working with the Arduino and the Arduino software team and trying to bring it back to the API. That will be more competitive as we move forward, but that needs to be, I think, community effort. We will list those supported shields which we know work and have been validated, as well as PCIe cards, for instance, that we know work and have been validated. But that's something we're going to be working on.
So one feature that's quite innovative is the fact that you can actually switch from 5 volt to 3 volts.
Yeah.
I know by moving a chip. So if you depending on what kind of shield you want to use.
It supports both the 3.3 and the 5 volt. But let us know what shields you're playing with, you're looking at. Now, obviously, everyone has their own favorite shield. A lot of people build their own. But we are planning to support the entire performance that Massimo has up on the site at convention.
Okay. Thank you everybody for coming. It was a short presentation, but we wanted to answer your questions and show you a little bit more about the product. And if you have any more questions, you just go to the Intel booth. Intel booth at the end of the aisle, and they will be happy to answer your questions. There's a bunch of demos and try to get you a home.